So let's take a look. Okay, so we have open circle here. And now I want you guys to write down the domain and the range. Okay, try it.
Is the one on the end closed? Closed circle?
The last one, yes, closed. It's closed. Yeah, thinking.
Trying to think of test dates and everything. I'm trying to figure it out.
Okay. Your mind. How about the other courses that you take? What kind of method do they, what kind of format of the test they take?
They don't do the problem. All of my courses, they don't do Proctor U until the final.
Oh, okay. That would only do once.
Yeah, they only do one Proctor U, and that's for the final. But for the most part, they just give us the test, and we go in and take the test and just submit it. That's all.
Oh, okay. I see.
My only other class is English, and that's online. And I don't have like all that. That's just essay. I don't have to talk to you with that. I just have to talk to you with this.
I do monitor ED for my biology class.
Oh, you have the.
It's
Okay.
it's a proctor and sorry, it's just a different one.
Okay, I see. Still, they at least proctor some tests, right?
Oh, that one's every test, every quiz, everything.
Okay, so it's reasonable. Yeah, I see.
Yeah, that one's got a lab, so it's like a whole other class.
But you guys need to get used to the proctor U or proctor, any proctors, because in the future you're still gonna use a lot.
Yeah.
Yeah, you need to get used to the proctor.
I don't know. I think I'm gonna have to buy a stronger computer.
Me too.
A stronger computer.
But I think for me personally, this test proctor was actually easier than the first test.
Of course, I intend to give you guys easy one because that's you guys will get very nervous with the proctor U. I already think about it.
Yeah, I think I did better on this one than I did on the.
Of course, a lot of students get better. I can tell from your score. A lot of students get better, but some of you, I can tell it's not so good because of proctor U stuff. Okay, but I will give you guys some policy later after I grading all your score.
I was nervous of if it would work or not. Once it worked, I was okay.
Great. Okay, so now let me write down the answer for you guys. So for the domain is from the left to right. All right, from left to right. So you start with left. Use a vertical or vertical pencil, right? So go along the left to the right. The first touch here is this point. The first touch, right? Move is this point, and this point is open circle. That means it's not included. So use the round bracket. Okay, use the round bracket. That means it's not included, right? The first touch. Go, 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 go. Second touch, we see another open circle. You need to stop it. Okay, when you see the open circle, you always stop it. And that means that is a break point. So stop here. We can say that is a 2, right? It's a 2. Okay, and then we continue from 2. From 2. Go, 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 go to here. Stop here. And that is closed circle, right? So included. You see it? Okay. And then for the range, the same strategy from downside to upside. So go, 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 go. The first touch is this point. Okay. Now here's the tricky part. Although here's an empty point or open circle, however, this open circle, it seems this guy shouldn't be included, right? When you go from the downside to upside, the first touch is this point, and you can see this is open circle. It seems this point shouldn't be included, or this value shouldn't be included. Okay. However, you can see this is a closed circle. Okay. You can see this one is still included, right? This point includes this one, right? So you still need to use the square bracket because this one is included. Okay. Then let's goes up. Go, 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 goes to end here, right? End here. That's the open circle. And we can see this 2 is not included. Do you see it?
I don't see it. How did you see that it was included? It was because it had 3 on the same line too?
Yeah, on the same line. You're right, on the same line.
So then, the three then makes it change from the parentheses to the bracket.
Just make changes at 1. Did
Yeah.
you see? So from downside to upside, the first touch is what? Is this one, right?
Right.
Because here is an open circle, you guys probably think 1 shouldn't be included. However, since here we have another point, 3, right? 3, 1 is included this point, right? Included this y value 1.
Which makes the other one.
Yeah. So makes this one included.
Okay, so anytime I have more than 1 point on the same line,
You need to consider all of these points on this line, whether this is open circle or it's closed. If that any point is closed, that means this point is included.
okay, and included is the bracket.
Yeah, square bracket.
Okay.
You're very familiar with the closed interval, right? The interval. When I teach the inequality, I teach you guys the interval format, right? How to use interval format to express the inequality.
Right.
Yeah. So that is if that's the value is included, we always use the square bracket. Did you see? Did you still remember?
Okay.
If it would have been 2 open circles, would it have just stayed the same?
Yeah, stay the same. If there's an open circle here,
Yeah.
then you should use a round bracket
Right.
because this point is not included. Is that clear?
Okay.
Yeah.
Okay.
Okay.
Make sense?
Makes
Good
sense.
job. Good job. Good job. You can try to use the pencil. Okay, try to use the pencil. Follow my method if you have any trouble to find the domain range. Okay. Now I'm gonna give you guys another example. And I wish this time everybody gonna make it.
You got to move it down a little bit, Mr. Key.
Sure, no problem.
Thank you.
Okay, so here we have pi over 2, okay? Pi over 2 pi, okay? Now 0 pi over 2 pi, and this value is 1. Now write down the domain and range, okay? And be careful, we have the arrow, 2 arrows, that means goes to infinity, right?
Is that an open circle on the 0, 0?
No, this is a closed. These 2 are closed. Only the top one is open, okay? When you reserve the test date from the testing center, I wish you guys can finish it before Thursday, okay? Before Thursday. So tomorrow, Wednesday, if you can finish all the tests on Wednesday, then I can grade all your tests before Thursday, and I can post all your grade, okay? Otherwise, it's too late, okay? So I want you guys reserve the test date before Thursday, okay? If possible. Otherwise, other students gonna complain, where is my grade? They always email me a lot. Where's my grade?
So you extended the test?
No, I didn't extend the test because some students have a problem with ProctorU, so they're gonna do it on the testing center, okay?
Can I say the answer?
Could you wait 1 minute? I want to wait some other students, okay? I know you are very smart. Be patient. Okay, now let me write down the answer on board. So the domain. So from the left to right, right? So you can see this curve has an arrow, that means it can go to infinity, right? So from left, you can first touch always from the negative infinity, right? From negative infinity, because this curve can go to a negative infinity, right? So should be a negative infinity, right? On left, negative infinity, go, 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 go. The first touch, the open circle should be at this point, right? The first touch is this point, and you can see the x value gonna be a pi over 2. That's the break point, okay? If you see the open circle, that means that is a break point. So we start with pi over 2, and you can see we have another arrow, right? Arrow means goes to infinity. So look, go, 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 goes to infinity, right? So we have like that, right? Goes to infinity. And for the range, this way, right? So go, 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 go. You can see this curve goes down to the infinity. That means from negative infinity. All right. And go, 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 go. Everything should be very smoothly until you see the open circle, right? You stop here, and you can see that is 1, right? Stop here, and the 1 is not included. That's it. Okay. Clear? Okay, I'm gonna stop the domain range here, and today we're gonna learn some new stuff. Okay, new stuff. So I gave you guys some definitions. The first definition is f plus g x. That will be fx plus gx. F minus gx should be fx minus gx. Gx, fx, gx. F divided by gx, or fx divided by gx. Okay. So that's the 4 formulas. And be careful, from the mathematical way, we have different notations. For example, here, if we have round brackets, f plus g like that, that means fx plus gx, okay? If we have f minus g round bracket, and that means what? Fx minus gx. If f dot g bracket means fx times gx. F divided by g round bracket, that means fx gx. Just different notation, okay? Notation. In the high level mathematics, people use this kind of notation to represent these operations, okay? So you guys just needed to get familiar with such a notation. I think it should be very easy. Let's take a look. An example. For example, fx equals x squared plus 9 gx equals 3x plus 5. Okay. So the first one will be fx plus gx. Should be x plus 9, 3x plus 5. Okay. And then you're going to get x squared plus 3x plus 14. Okay. So because here is fx plus gx, that means what? That means you just need to plug in fx here, plug in gx here. right? And then do the combination, x squared plus 3x, 9 plus 5 is 14, okay? The same things. For this guy, you need to be a little bit more careful. Here is a subtraction, right? So fx gonna be x squared plus 9. Gx gonna be 3x plus 5. Okay, when you plug in, be careful. You'd better use the parentheses. Okay, parentheses, because here we have negative. Okay, or subtraction. So be careful when you plug in the whole things. You need put the parentheses in case you make a mistake. Okay. So negative, right? And then combine it, you're gonna get this guy, right? This guy. And how to calculate this guy? Would be fx times gx. And we know the fx is gonna be x squared times x squared plus 9, 3x plus 5, right? And the distribution. Okay, distribution. We have what? We have 3x cubed, 5x squared, 27x, 45. Right? Distribution, and then combine every terms. Okay? And the division means fx divided by gx. So for the division should be very straightforward. Plug in the numerator x squared plus 9, and the denominator is 3x plus 5 is a gx, right? Just plug it in. Okay, now I want you guys try this example for me. You can try it by yourself, okay? Example 2. Try this one for me, okay? Calculate these four notation. F plus G, F minus G, F dot G, F divided by G, okay? Okay, I'm gonna write down the answer on board. So, the first one should be fx plus gx. We're gonna get like that, right? Combine. The first one is always the easiest one, right? Just combination. Okay. If you keep a very good habit, always put a parenthesis there. Fx, that means this guy. Gx, that means this guy, right? Combine it. And second one, right? And then plug in, and then you're gonna have, you cancel out, right? And third one gonna be what? F dot G. Okay, so we have fx times gx. We have x plus 1. Okay, so we have distribution. Okay, and then you're gonna have what? You have x cubed plus x squared plus 1. Okay, distribution, right? Distribution. And the division, we're gonna have what? That is here. Right, and then plug in the fx, x plus 1 divided by the gx. Okay, that's it. That's it. Now, let's move on. Let's move on. Okay. So today we're gonna learn the section 3.3 properties of functions. Okay. Now let's take a look at the definition.
Was what we just got through doing, was that part of domain and range?
What?
What we just got through doing, was that part of domain and range?
No. This is not part of domain and range.
What was the section we just got through doing?
Should be I think it should be 3.2 or something like that. I forget in which section. 3.2 maybe. If you couldn't find it, just email to me. Okay. You still read the textbook? Do you?
Yeah, I go to the textbook. It's on Math Lab. You can find it on
Oh yeah. You're right. You're right. Definition. A function f is even if we have this guy, f negative x equals fx. A function f is odd. Oh, odd. That means f negative fx equals negative fx. Okay, that's a traditional definition. However, we have a theorem going to help you guys to check whether a function is even or odd. Okay, odd. So let's take a look at the theorem. Let's take a look at the theorem. And a function is even if and only if. Okay, IFF means if and only if. Okay, do you understand? IFF, if and only if. Okay, its graph is symmetric. With respect to, okay, with respect to, okay, with respect to. WRT means with respect to the y-axis, okay? If what? The graph is symmetric with respect to y-axis, that means that function is even. Okay, the keywords is symmetric with respect to y-axis. Okay, now let's take a look. Odd. A function is odd if, only if, its graph is symmetric with respect to the origin or the original point. Original point, okay? Original point, origin, okay? So the keywords odd means symmetric with respect to origin, okay? So those two are very important and are gonna help us to recognize whether this function is even or odd. Let's take a look and picture. Okay, now if I give you this function, then the graph is here. Is this function even or odd? It's even, because when you have this part of curve fold over to the other part, you're gonna find this curve and this curve gonna be overlapped, right? If you fold this part of curve over to the other part, you're gonna find these two parts gonna be overlapped. So that means they are symmetric with respect to y-axis. Is that clear? Overlapped, right? These are symmetric with respect to the y-axis. So that is even, okay? Because you can see, you fold over this curve to the other side, you're gonna find these two parts overlapped with each other. That means that is symmetric with respect to this y-axis. Clear? Okay, very good. If you understand this, you just got this is even function. Okay. Now let's take a look. This guy. For the other function is a little bit tough. You take a look. Okay, so for this guy, you can take a look. For this guy, you can take a look. If you pick any points from here, okay, and this is origin, right? Origin. If you take this point is here, if you fold over with respect to this origin point, fold over to origin point, you can always find another point corresponding to this point. If you fold over with respect to the origin, you can find another point here. If you find another point here, you literally pick a point, and you can find, if you fold over with origin, okay, fold over with origin, you can find another point here. It's overlapped, okay, overlapped. Is that clear? So here that means this curve is symmetric with respect to origin, okay? You just pick any points on this curve, you always can find another point on this curve. Okay, just fold over, pick a point, fold over with the origin, you're gonna find another point here. Is that clear? Okay, very good. Now try this one for me. So this guy is odd, okay? That is odd.
C would be odd and D would be even.
I don't don't speak it out because some students need to think. But that is E. Okay, think about it. Oh, F, the last one. Okay, think about these four. Okay. Did you guys vote? It's election day today, right? Did you guys vote?
Can't vote yet. Missed me by 16 days.
Six.
I already voted.
Oh, you early voted. How about you?
I'm 17.
Oh, you're
Same
17.
here. If it was 16 days from the date, I could vote.
Okay, so at least 18 years old. Okay.
That's so old.
How about you guys? Did you vote?
I'm 17.
Oh, unfortunately, you guys too young.
I haven't voted yet. I can vote today.
Okay, go ahead and vote.
I did.
Oh, so you are a high school student?
Yes.
Yes,
Oh, I couldn't tell.
I know, that's why I feel so old.
No, you're very young.
I don't feel young.
Okay, now let me do it on board. So you can see for this curve, we fold over this part to this side. We can find these two curves overlapped with each other, right? So it's even. And of course, for this curve, it's a little bit tricky. When you fold this part to the other side, you're going to find this curve is overlapped with each other. That's good. However, if you pick any points here, right, and if you fold over with the original point, you pick any points on this side, fold over to the with respect to the origin, you can find another point on this curve. Okay, and you find another point here. You're gonna fold over with respect to the origin. You always can find another point on this curve. If you find one point here, you fold over with the origin, you can find another point on this curve. Okay, so that means it's even and odd function, both of them. It can be both. Okay. And for this guy, it's very straightforward. It's symmetrical with respect to the origin. That is odd, right? Because you pick any point here, you can fold over with respect to the origin. You can always find another point here, right? You find a point, pick another point, get another point. So that is odd. How about the?
How did you fold it over to determine it was odd? It didn't fold over.
You fold over with respect to the origin, right? So you pick one point here, fold over with the origin, you're gonna get another point here.
But what makes it odd?
What?
What makes it odd? That's what I'm trying to.
So odd, if you pick one point here, right? You just fold over with respect to the origin. Origin is here, right?
Right.
So you connect this point or you whatever you want. If you fold this one to the other side.
I thought when it folded over and made it even, it was even.
No, fold over with respect to the origin. If you fold over with respect to y, that is even. That's the definition, right?
So if I folded over, it would land into y, into the upper part of y.
With respect to y-axis, gonna be even.
Oh, I see it now, because it doesn't fold back down like this. It just folds on one side like this.
Yeah, different with respect different things, right? Here's a y-axis, here's the origin. Did you see it? The difference? If you fold over with respect to y, you can say respect to the y, that is even, right? With respect to the y, going to be even. Right? How about this one? Neither, right? Good job. Good job. If you can fold over with respect to y, you can find the overlapping stuff. If you pick any point here, you can find the other point. Right? You can fold over and find another point. Right? So that is neither. Clear? It can be both. It can be neither. Okay? Is that clear to you guys? I think it's not too hard, right? Okay, so now let's continue. We have a lot of properties. Okay, a lot of properties. Use a graph
Is this section 3.4 or still
3.3, still 3.3, to determine where a function is increasing, decreasing, or constant. Okay. Guys, please type your name in the chat. I want to check your attendance. Okay. Please type your name in the chat. Okay, definition. a function f a function f is increasing on open interval I, meaning that any for any x1 less than x2, we have okay. And the second one, a function f is decreasing on open interval I, meaning that for any x1 less than x2, we have greater than x2. A function f is constant on open interval I, meaning that for all choices of x in I, we have this guy. Okay, so be careful. From this definition, we have very important step. We call it open interval. Okay, it's not about closed interval. It's about open interval. Okay, and the keywords for increasing, if you pick x1 less than x2, you always find fx1 less than fx2. If you pick x1 less than x2, you find fx1 greater than fx2, that means it's decreasing. Otherwise, less than should be increasing. If you pick any of them, you find doesn't change. That means that is constant. Okay. Now let's take a look the curve, okay, or the picture. Gonna help you guys to understand it. So for the first scenario, so for example, yfx. If we pick any point, 2 points, okay, and we can see x1 is less than x2. x1 is less than x2. And correspondingly, we have fx1 and fx2. Right? If you pick 2 points and you have x coordinate, x1, x2, y coordinate, fx1 and fx2. And we find the fx1 less than fx2. That means what? If we found x1 less than x2, we found fx1 less than fx2. fx1 less than fx2. That means what? That means it's increasing. Okay. And now let's take a look. B. Okay. And for this function, still you can take a look. You pick 2 any two x coordinate, and we find this less than, right? And you can correspondingly, you can find fx1 here fx2, right? Now you can see fx1 is greater than fx2. fx1 greater than fx2. So fx1 greater than fx2. That means decreasing. Right here, fx2 greater than fx1, right? That is increasing. And C, if we have a function like that, and you randomly pick any fx or x1 or any x2, you're gonna find fx1 always equal to fx2 because they are on the same line, right? So that means that is a constant. Okay, so that's an easy way to check whether a function is increasing or decreasing or constant. How to check? Just from the left to the right. We can see from the left, you can see the curve always goes up. That means increasing. Okay, just go from the left to right. If you see the curve goes up, that means increasing. And for this case, from the left to right, the curve always goes down. That means decreasing. And from the left to right, you can see the curve always keeps the same. The same, that means constant. Okay.
Doesn't matter how you put your f of x1 or f of x2. Doesn't order.
If you strictly based on the definition, you can use the first way. Okay, you can use the definition. But I teach you guys another way, just go through from the left to right. If you find the curve goes up, that means increasing. And the curve goes down means decreasing. If curve doesn't change, that means constant. That's it. Yeah, that's my way to help you guys to understand how to check whether it's increasing, decreasing, or constant. That's the easy one. Okay, easy one. Otherwise, you're gonna pick 2 points. Okay, based on definition. From my way, you just check from left to right whether it's go up or goes down or even the same. And here's some questions because here I also emphasize that it's open interval. Okay, open interval. So I gave you guys some examples. Why I emphasize.
Do you mind putting that page up one more time? I need to see. Open interval line or curve or whatever goes on the
No, I will show you. Okay, so for the C, you goes from the left to right. You will find the curve doesn't change, right? Doesn't goes up, doesn't goes down. So keep it the same, that means constant. Did you see it? From left to right, keep it the same. So the case B is when you curve or when you goes from left to right, you find the curve always goes down, right? And for the case A, when it goes from the left to right, it's gonna be goes up. Did you see it? It's a curve. Okay. Now, okay, so increasing or decreasing, always about x or domain, not domain, x coordinate. Okay, x coordinate. So from this curve, on what interval that is increasing, on what interval that is decreasing, or what interval that's a constant. Okay, so let's follow the strategy I told you guys from the left to right. Okay, so you go from the left. The first touch is here. The first touch from here, you can find the curve goes down, right? From left, you can see the curve goes down, stop here. And then you find the curve gonna goes up, right? Stop here. So from left to right, you find this curve. This part is goes down. Okay, and if it goes down, you can use arrow, right? Goes down. And from this point to this point, you find the curve always goes up, right? Right? From this point to this point, the curve goes up. See? And from this point to this point, you find the curve goes down. Okay. Now, after you mark down these sections, 1, 2, 3. 1, 2, 3. We have 3 parts. Okay. Then you can write down all the open interval for each section. For this decreasing, we have 2 parts. 1, 2. Right? Decreasing is these 2 parts. And increasing is this section. Right? This section. So increasing gonna start with negative pi over 2 and pi over 2. And be careful, it's always about x coordinates, nothing to do y coordinates. So from the negative pi over 2 to pi over 2. Did you see it? And be careful, use open interval, because definition requires open interval, nothing to do with the closed interval. Okay, so always write down open interval for the increasing, decreasing, or constant.
And that's when it's increasing.
Huh?
Open intervals when it's increasing.
No, increasing. For all the cases, you always need to write down open interval. Now let's take a look. Decreasing. Decreasing is from what? From negative pi to negative pi over 2. Union, because we have 2 parts. Pi over 2 and pi. And you can see it again. We use open interval. Okay. Always use round brackets. Round brackets, that means open interval or parentheses. Is that clear?
Yep.
Okay. So we have 2 sections are decreasing. One is from negative pi to negative pi over 2, right? From this point to this point. That is negative pi to negative pi over 2. And another section is from here to here, is pi over 2 to pi, right? And we just union it or combine it together, right? So we use the union. Is that clear? Do you have any questions? So the strategy I already told you, from the left to right. So from the left to right, mark down the arrow. Okay, if it goes down, use this arrow, and if it goes up, use this arrow, right? Okay, now I'm gonna give you guys an example. Later, you guys try it.
Mr. Key,
Question.
I was wanting to know if it would be okay if I went ahead and left, because I have to get to work and I understand everything you're doing.
Okay, go ahead. You can left.
Will you count me absent, or I'm good?
You're good.
Thank you, Mr. Key.
Okay, try to find the increasing, decreasing, or constant.
Is there a point on the end?
Doesn't matter. That's okay.
For 4 years?
If there's an open circle, it's okay, but because we use the open interval, right? Okay, let me do it on board. From the left to right, okay? From left to right, you can say the curve goes up to here. This section goes up. And after that, this point, we find the curve goes down. And after this point, the curve goes up. So we have 3 sections. 1, 2, 3. 3 sections. So for increasing goes up, we have these 2 sections. This section and this section, right? This section and this section. That means from 1 to 2, union 3 and 4. Okay. So this part and this part. And always use the open interval. That means round bracket. Okay. And for the decreasing, we only have this section from 2 to 3. And of course, we don't find the constant. Right? That's it. That's it. Okay, I'm gonna wrap it up class here. Thank you for coming. Have a nice day. Okay.
So if there's an increase in, are you defining the increase in the decrease, then the constant is just that blank?
If the constant, that means that the curve like that.
Yeah, but say, like, there was no constant there, so we just leave that one blank.
Oh, yeah, no constant. Yeah, no constant. Could you type your name?
You want us to?
Yeah, I type your name here.